here, and hopefully you had you were able to eat something. I know the queue was quite long. This talk is I built this talk because, as I say, I've been working as a customer for 11 years. Particularly, I've been working on large-scale systems, and I was a huge fan of the Netflix kind of way back in the days. So some of it is inspired by that, and then also to show you that 10 years ago when we were trying to build large-scale infrastructures and systems, multi-region systems, it took us, 5 to 10 people for a year to build things, and now in a couple of clicks you can build this. So as I say, it's pretty ridiculous how things have changed, and hopefully I'll show you some of those things. As I say, the session is organized like this. We're first gonna jump a little bit into reliability and availability, because you don't just start building large-scale multi-region active systems out of nothing. You need to have a purpose. If your purpose is to look cool for your company, that's probably gonna get fired. You need to have a business purpose, right? So we're gonna think about it, and then why and how, and then I'll show you how I built this demo, and then what powers it and things like that. So some hands-on will go through all the services. Happy, again, it should be a discussion. Feel free to ask, just politely, don't do like in Israel. Sorry if you watch that on video. The first thing that we need to understand is a little bit talk about reliability and availability. And one of the big quote that really changed the way I think about systems, especially large-scale systems, is from Werner Vogel. Not because he's CTO of Amazon, is because really he points very well that failure is a given in any system, right? And if you, and many of us initially try to architect solutions around failures, right, to prevent failures, but actually you should embrace failures. And architect solutions with that in mind makes you do very, very different decisions. And some of them I'm gonna talk about there. You don't have to understand in systems, they are gonna fail, right? And there's a few reasons for that. There's 3 types of failure: early, late, and random failures. Early failures is everything when you deploy your code, there's a bug associated to it. It takes some time to iterate through that code and eventually fix it. And then the late failures, these are the ones that often people think softwares don't have late failures, but I give you the example of configuration drift, right? How many of you have experienced failures because of configuration drift that, you change hot fix on your live environment, forget to commit that to your GitHub, go on the weekend, come back on Monday, totally forget, and then it stays there. And then one day you do a deployment and the things are different, everything crash. I've experienced that several times to say that it's actually one of the most common, for the rest of the world, in terms of failure, the most common way to fail the systems, configuration drift. So yes, there are late failures. And of course, you have the random failures. I've seen squirrel eating cables. I've seen sharks eating transatlantic cable that took data centers down. Drunk truck drivers hitting data centers and taking things down. Aurora, the sun flares, electromagnetic, taking down some electromagnetic systems. There's basically things you can't control, right? So you're gonna have all the time random failures. And of course, the random failures are not gonna be the ones you select. They are the ones, they will always the ones that you don't expect will happen, right? And this is very important because it really means that you need to figure out how to do things. Now there is another problem. It's like we live in a world where velocity is very important. You need to deploy very often. That means actually your early failures are repeatedly happening. Simply because if you don't deploy often, your competitors will, or your customers will go see somewhere else that iterates faster to get what they want, right? So we end up with kind of a crazy what we call bathtub, but actually this is not looking anymore like a bathtub. It's really quite silly. So talking about availability is very important because failures will take you down, so you need to understand availability. And there's a simple equation for availability. which is the mean time between failures divided by the mean time between failure plus MTTR, which is mean time to recover. And if you look at this equation, your main purpose is to get that close to 1 so that you are 100%. So that means your MTTR needs to be as little as possible. The more you increase your mean time to recovery, the less you'll be available, which seems pretty obvious. So your sole purpose is to do what? Is to automate, invest in automation, self-healing systems, and things like this, because that's the only way you can fight for availability. So those are kind of a given. Now there's still a lot of work to do on the infrastructures, and I'll talk about some of them. As well, this slide is quite interesting. A lot of people talk about availability in terms of the nines of availability. Very often you hear, we are 4 nines available, which means yearly you have 52 minutes worth of downtime for your credit. How many of you have experienced very large scale failure? Very large. I'm the only one. Wow, cool. You? So some of the failures I've experienced, it took us already about 7 minutes to get paged. In fact, the escalation path of the paging system failed to start with. It failed to realize that there was a failure in the system. So this is already a cascading failure that happened. And then we had configuration drift, so another failures when we started to do some deployment. So it was cascading like this. It took us several hours just to fix everything. And very often, large-scale failures, if they involve humans, you will be into the hours. And accumulate that like to several times a year, you easily end up into between the 2 and the 3, more often in the 2. So what I'm saying here is if you try to go there, and as the equation shows, you need to invest in mean time to repair. That means you need to invest in self-healing systems where no humans are there. That means 2 things. That means you need to architect the systems to be self-healing, but you also need to understand what kind of failures you've had, do a post-mortem, and automate that. So these are kind of things I want to lay out there. Now there's a couple of things that you need to understand from the architecture point of view. If you have 2 systems, X and Y, in series, what happens? Anyone wants to take a bet? If, for example, my component X is 99% available, and I put it in series with another component which is 99.99, actually the overall availability of the systems will be lower than any of those components. And this is against what we think, my chain is as strong as the weakest link. In fact, it's actually weaker there. And this is important to realize because you might, and all systems and all large-scale systems are actually architected in series, and you need to be very careful what you do with this. Now there's another equation, that you need to understand is this one, right? Now, this actually much cuter equation first to start with. It gives you a lot of benefit because now if you take a system at much lower availability, which is 99%, and you make it in parallel twice, you go into a 4 nines of availability, which is pretty cool. And then if you make it 3 times in parallel, you are at 6 nines without you having to transform anything in the architectures. You just duplicate the channel, right? So that's quite the straightforward solution to increase your availability. And, well, that's kind of obvious, right? And then, of course, we go now to an AWS regions. And in AWS regions are architected like this, around AZs. I've discussed already what an AZ is. They are geographically separated, still separated low enough so that you can do synchronous replication, 1 to 3 milliseconds of latency between AZs. And what we do is we always bitch our customers to always architect solutions around 3 AZs, simply because you increase your availability, right? So if you wonder why AWS always remind people about this, it's simply because of this equation. And actually, this should be the first thing you do into an architecture to be highly available. And you can, of course, take this further, and we're going to do this today into regions, right? Because the regions going into multi-regions is the same equations that we are looking for. And some of the regional service that are really important here to talk about, some which have by default that are architected on top of 3 AZs will help you to have a higher availability out of the box, right? Because they have 3 AZs under the hood, and some like RDS, SD-Cache, and Elasticsearch, you can with one click enable multi-AZs. And I strongly recommend that if you start to work into increasing your availability, you look for services that are by default architected across 3 AZs. Right. And these are what I'm talking about, okay? And of course, serverless, because we're on the serverless track. As I said, my biggest interest here in serverless is availability and fault tolerance for that very purpose, okay? Now, you're gonna say, of course, making system highly available have costs. It has costs because if you want to create self-healing systems, if you want to implement high availability, you will need to invest, right? So the cost of complexity, or the complexity increases, but the cost as well. So it's something that is very important. You don't go into architecting very, very highly available systems if you do not need as a business. This is why you need to figure out what is your availability that your customer, that you're offering to your customers, right? Because then you can work backward and figure out what you're working for or working towards. And of course, there's something very important to remember is reliability and availability are 2 different things, right? You can have a very highly available system that returns errors. It'll still be available, but it'll return an error. And so reliability is that. You want to have a system that is highly available, but reliable. So that means it returns the truth every time. And these are 2 things that are totally different. And that you want to work about. And when we talk about reliability, actually I have 3 lessons, not 2, that I want to talk about. And one is the most important thing that I've experienced as an outage is called exponential backoff. Exponential backoff works like this. If there's an error in the systems, system A tries to call B and there's an error, generally speaking, often the system do a retry immediately, so there's a retry. So that means you flood the networks with retry. And if you think about very large-scale systems all retrying at the same time, you end up in massive, massive failures. And this exponential backup was introduced when they built the TCP protocol back in the days for the exact purpose of saving networks from being flooded with retries, right? And very often, when you bring dependency into your software, you bring libraries that connects to Redis, a database, and stuff like this. Lesson number 1 you need to do is verify that they implement exponential backoff, because one day you'll experience a failure in a distributed system, and all of them, when you bring them back up, will try to retry. Or if they have an error, they will retry. And if you do not have exponential backoff, they will go into an infinite loop almost of retrying, which will take your system down. So something that is very, very important to make sure you have in your libraries is this. Now you see the wait function is very simple here. You can make the wait function a bit more reliable, not reliable, but more efficient. By adding a random jitter into it so that actually the retry is a bit more randomized. But nonetheless, this is something that is super important. It took systems down twice with libraries that we are thinking in our system. So my previous companies, we had dependency on Redis, and some Python libraries that we used to connect to Redis for queues didn't implement exponential backoff. We had 150 microservices using queues, Redis, trying to do retries at the same time. Took all the rest of the system down. For library, we forgot to verify that had exponential backoff. So it's costly. And then another important component is circuit breaker. This is a saving the life type of thing. In fact, if you follow how Netflix architect their solutions, they use a framework called Hystrix, which implements circuit breaker. Circuit breaker is very interesting. Imagine I have a component A trying to call a database. Very often you give the URL of the database to the component A to call it, right? Circuit breaker, you do something different. You pass an object, and that object has the URL, but it also tracks the number of failures of that dependencies, so that you can define threshold after which, if you have some errors, you can circuit break that, so you don't call it anymore, so you can start isolating faulty component from your architecture. And this is very important, because then you can do degradations of service without having your system down. A very important one is, I always ask customers, imagine you're Netflix, imagine you're running a video streaming services, and your authentication system goes down. What do? Do you let people watch for free, or do you kick them out? Yeah, but not everyone says that. Is your system, when you connect into, for example, Instagram, Facebook, all that, if your login don't work, most of the time you can't use the services. Like my bank, what do you do? All this kind of stuff. So those are interesting, right? Ideas that you can start to implement in the path of critical services, right? Figuring out, is my dependency very critical? Can I live without it? If you can live without it, circuit breaker is very important, because if you do not have circuit breaker, a timeout in calling a non-critical service will bring it back to the UI, to the user, with the waiting, blocking UI. All right. So all this kind of stuff are very important. And of course, we're talking about asynchronous systems. So as soon as you go into distributed systems, you have the cap theorem that says, in presence of a partition, you cannot have both availability and consistency, right? So you need to make a decision which is that you want. And in distributed systems, often, especially around the web, we talk about we want to be highly available, therefore we need to embrace eventual consistency, right? And so that means you also need to embrace asynchronous systems. And asynchronous systems, two patterns that are really fabulous for that, isolating component A from B, is message passing, whether you want to have a listener or a pops-up pattern. And then you can do something like this, right? So you can isolate your API to let's say the business logic through queues, right? So if you have an API call happening there, instead of passing the request to the business logic, you actually give it an ID and then return immediately. And then this ID goes down into a queue, and my workers here, when they are available, they will take that and then process the job and then push this into cache, the results, right? And then you can use that result and then use push notification to send that to the user, so that your user doesn't have to poll all the time for the data. Is it here? Is it here? How many of you have kids? Dad, are we there yet? Are we there yet? Are we there yet? You probably would kill your kid after 3 minutes. This is the same problem with backends. You want to save your architectures from calls that are not important. You don't want to call if there's no results, so it's better to push, right? And that architectures with separating components through queues is very cool. And if you want to know more about reliability, there is actually a whole well-architected framework that has been published. There's white papers and things like this that you can download. There's a bunch of them. Or I published yesterday in Munich, I did a talk on chaos engineering that takes that to very, very deep, and it's online as well. You can get it from Twitter. I've posted on Twitter. So the question is, why do we build multi-regions, active-active systems architecture? It's a good question, right? Why do we want to do this? There's few reasons for that. The most important reason, which becomes very popular, is that now companies have to go global, right? That they have to have users around the world. And if you have a user, for example, here in Germany, and or if your backend is in Germany and your users are in Australia or in the US, you by default will have latencies, right? And 300 milliseconds latency round trip, 600 milliseconds, almost 1 second of latency. This is if everything is fine, right? And same for US. And that's a lot of data. Just to give you a point, we did some measurement at Amazon.com that 100%, 100 millisecond increase of latency on the website generates a drop of 1% of sales. That's insane, and that's true data. 100 milliseconds latency, which is you can't even see it as a human, but still it results in 1% drops of sales. So latency is very important. So customers are now deploying solutions closer to the customers. That's why we go multi-region. And then another good reason is disaster recovery. Right? There are some applications which need to be always available, like banking, insurance, or Netflix. And Netflix does exactly this. If there's a critical service that is going down in one of the regions that may impact customer experience, so imagine if authentication systems go down, the service, they will move into without authentication service, they will move into a free for everyone who doesn't care. They'll still send the videos, but they will start moving traffic slowly to another regions, right? They will actually move in about 10-15 minutes all the users of a region to another region so that they can recover the critical service in 4. It's the same idea. If you have, the question is, imagine you have a database and you have masters and read replicas because you do a read-write sharding. Imagine your masters go down, so you can't write anymore, but you can read. Can your application support read-only? Probably. So you can move into, you can degrade, you can have a circuit breaker, moving your application into read-only mode, and then initiate a move of traffic to another region so that you can recover slowly. Right. And this is a very good way. Many customers start to do this. So it's called graceful degradations. Right. And of course, business requirement is also customers that by law or by law need to actually have data separated by hundreds of kilometers in different regions, even in the same countries, but in US, for example, or in Japan, or things like this. And the important thing that that actually started the whole phenomena of multi-region building is an outage that Netflix experienced in 2012, which was an outage that was not caused by Netflix itself. It was a break. It was an AWS fault. And what happened is there was a problem in the ELBs data plane, and that took down the ELBs of the regions in New York East, where Netflix was deployed, which has been fixed now. Don't worry. You can safely use the ELBs in the region. But what they started to do is they started to think about a system that would be able to be resilient to full region burnout, right? And this is why actually they were the first to start really large-scale multi-region failure recovery. And they made an update of that blog post in 2016 when they started to do 2 regions in US plus the one in Europe, because now they have customers in Europe, so they also use the latency and then the failover benefit, right? So it's 2 business benefit for them: better latency for the end users, but also better failure recovery. And then, of course, what they started to work on is a set of tools that would be able to test these kind of things, because when you have large-scale systems like this, functional testing and unit testing are not good enough. You need to move to a new kind of testing, which is called chaos engineering. And these are some of the tools they are using. They created some monkeys. They call them the simian armies. The first one is this chaos monkey here, this crazy little boy, which randomly shuts down instances in the region to see if you can recover from failures. And then the big gorilla there is the last breed of the simian army that shuts down the full regions. And they do this once a month in production systems to test if they are good at recovering from failures. Just to give you an idea, in production systems, right? It's no joke. So they simulate the full region. They shut down the data center and see if the service can recover. I'm not saying you should just go tomorrow morning and start shutting down the database. I did not say that, right? There's a lot of preparation to do under the hood to do this kind of stuff, right? So how do we build multi-region systems? The first thing to understand is, as I said, you need to move into the world of asynchronous systems, because if you are building large-scale systems, you deal with synchronous systems, or systems that have higher latency between than 5 milliseconds between systems. And when you're there, you're in asynchronous mode. You don't have a choice. Otherwise, your customers will just wait, because if you have more than, let's say, 100 milliseconds latency to get a result, your process are gonna go like waiting all the time. So what you want to embrace asynchronous processes as well, so that you just can continue doing tasks and your system can continue working, your UI can continue working, even though things are happening behind the scene. And now it's totally possible to do this as well, because we started to build what we call the Amazon Global Network. And this was announced in 2016 by James Hamilton, who is a distinguished engineer at Amazon. And what he announced is that we built, actually, between all the regions in the world, our own dedicated network, so that now when you want to do global multi-region systems, you are not going over the internet anymore. Some of the functions, especially if you use AWS services, will go on top of our own network, and it's a redundant 100 gig links between each region. So very big. And with that came a new feature called multi-region, multi-VPC connectivity, and that allows you now to do VPC peering between two regions. Right? So you can put regions into VPC. Can we stop just a second? That. My nose had tendency to start bleeding, so it just started to do some problem. All right, so with the multi-region, we were able to start to do VPC peering between regions. And this is great because previously people had to maintain VPCs between different regions and maintain several links, and it's never been easy. So now you can do things like this between your VPC, which is great. Then there's another function that came that is very interesting for especially static assets, video, images, libraries. Inside S3, you can enable cross-region replication, which allows you to move automatically data from an S3 bucket to another bucket into another regions. And just to give you an idea of the replication speed, Netflix, not with S3, but with Cassandra, they have Cassandra clusters in different regions, and they tested 1 million writes inside a region, and 500 milliseconds after that, a read into another regions, and experienced no data loss. So it was really fast to do this kind of things. Of course, you have this 500 milliseconds. So again, I said, eventual consistency needs to be your motto when you architect solutions. And then there's another feature from RDS that is very interesting to use, and this is, I already mentioned, is that you can do read and write sharding. So that means you can start doing read replicas. and your read replicas are asynchronously done to another regions. Right? So then you can have regional customers doing all the reads into a region. But the problem is, of course, when you want to make a write, the critical ones needs to happen inside the master cross region, which is kind of an anti-pattern of multi-regions. But nonetheless, currently is the only way to do this. Now there's a cool things that was just announced, is we announced Aura Multimaster, right? This year, so this is something totally new. First, it will be within regions, in different AZ. You'll have multi-masters in each of AZs that will also have replication. So that means you have 0 downtime first if one of the masters go down. But then you can do very fast read and write sharding inside your region. And we're taking this actually multi-region as well. So by the end of this year, you'll be able to use Aura masters everywhere around the world. So I'll have to change the slide when my master is only in one region. And which is great, because then it's you do not have to maintain bin log replications. How many of you have had to do this in their lives? Bin log replication? No, never. It's the worst job in the world. And it always went down. It was a misery. And now, RDS and Aura, they do this for you. They do the replication, they maintain the replication. It's just too easy, which is great for you. So this was announced, which is going to make things very, very good. But if you already want to build stuff, you don't have to wait the end of 2018. In fact, DynamoDB already support what we call Multimaster, right? And DynamoDB is the same database that powers Amazon.com. In fact, we moved back in the days from Oracle to Dynamo because in the late 2000s, they started to analyze database requests and realized 70% of our requests to the database were not transactional. And we were using transactional database, which was stupid. So we moved into Dynamo, which actually was built for the very purpose of scaling infinitely at Amazon. And now Amazon, during Prime days, which are kind of one day where we have very big sales at Amazon, peaks at 13 million requests per second on the database, which is pretty amazing if you ask about it. There's other numbers which are pretty cool as well. But now DynamoDB, actually we just released a service called Global Table. And our Global Table takes this master, multi-master, multi-region ID already available for you. And it's GA, it's available in all of the consoles for everyone to use. What it does is you create a table. It has to be an empty table to start with currently. Eventually, we are releasing features to move existing table into global table, but not currently. You need to start from an empty table, and then you can, with just one click or one API call, add regions where you will have master deployed, and then each region can just call their masters. And we'll do the replication and especially the conflict resolutions. And the conflict resolution applied for DynamoDB global table is last write wins, right? Which is very basic one. There's no magic there. We don't try to understand the query. It's very straightforward. And just to show you an idea, DynamoDB streams works like this. DynamoDB global table works by using streams, and streams, DynamoDB streams are a feature of DynamoDB that you can enable independently of global tables. That you can, every time you're going to put data into DynamoDB, it can create an ordered stream of all the changes that have happened in your table, right? You can do the new versus old and old versus new, all this kind of order. And then you can hook Lambda functions to do some additional work on top of this. This is actually used very often in the closed loop to do data augmentation. So a very common way of doing this is if you have an application that uses the postal code, instead of asking the entire address of a person, you will just ask the postal code, and then you have a Lambda function that takes the stream that says that, and then check the address of that postal code and add it to the database after that. So you can do cool stuff without asking too much information to the user. And of course, one of the most important service to do this kind of large-scale system is you need to have a dynamic routine. And Route 53 is our domain name service that you can use for that. It's the only service that has 100% SLA, which is quite interesting. And it has a lot of different things that you can use. Especially it supports what we call the traffic policies, which are policies that you can set up in Route 53 to do, for example, latency-based routing. In that case, if my resource is in A is high latency, all the traffic will go to the lower latency resource. Or you can do GeoDNS. This is used, for example, Netflix, Instagram, Facebook, to separate people from different regions so that they have a database in Europe, in US, and things like this, and orient the traffic from those people to the right regions. If you more into control things, weighted round robin is one, and this allows you to do, of course, the round robin, which is 50-50 between resources, but you can actually affect that. You can have 10%, 90%, and this is used very often for canary deployment as well. So you can start with 1% and 99% of traffic to a resource that has, for example, a new version of your software, and then you can test that version of the software and programmatically go back very fast to the old version if you experience some issues. Right. So this is great. And all those three policies are also complemented by what we call DNS failover. So basically you have a health checks on each of your endpoints or resources, and if any of those fail, then you go into a DNS failover. So all those can use DNS failovers as a secondary routing protocol, dynamic. All right, so let's look at it. How do we do this? Because that's the point, right? I want to show you first how you do this into DynamoDB. Do you see DynamoDB earlier? So in DynamoDB, I'm here. I already have a table called Dynamo Serverless. You could create a new table, for example, let's say this, and then client ID, create. This is as hard as that to create a database in DynamoDB. And you'll see a couple of things. There's a new, what is it called? A tab called Global Tables. My network is really bad, so I'm not sure what happens. But I'll go to wired network. Maybe that'll help if it works. All right, cool. Okay, so let's go there. I have a Dynamo serverless table here. You talk about demo gods, right? That's always like that. Oh, it should be created now. Ah, cool. So I have my new test table here, and then you see there's a new tab here called Global Table. And as you can see, to start using Global Table, you just need to enable stream. That's it. All right. And then what you do, you can start adding regions here. And for the moment, there's only 5 regions supported with Global Table, and Frankfurt is. So you can actually do US to Frankfurt or Ireland to Frankfurt. So here, we'll add a region here in Frankfurt. A replica will be created, and a master will be created in Frankfurt. And then you can go to the table and see. And you can add, all the different 4 regions that you want. All right. Cool. So you see, I have my yes, Dennis. No, so that's what I said. You need to start from an empty table currently, but we're releasing eventually to come ways to do it on tables that are already existing, but it's not yet possible. All right, cool. So this is quite easy. Here you can see I created a table with Dynamo serverless here with a region in Ireland and Virginia, and then I've emptied it so you can start creating items, feedback IDs, for example. This is just and my God, I'm so innovative. And then you see my item is created here. And then you can search for your items. But this is not this one, so I'll switch here. My item here is been now moved to another region. So here I'm in Ireland, and then the same table in North Virginia, and it also has the support. Now you see there's 2 fields that have appeared here, which I didn't add myself. You see, which is the regions of where this was created, and I created the ID in Virginia, so US East one. You see, this is the AWS update regions, and then this is the time at which the object was created. So you can also monitor your data and know from which region that particular data is originating from and things like that. So you can start, experiencing. You can start imagining Amazon.com being powered, all the website being powered like this, synchronizing data between regions, things like this. And this is very easy to do. So what we're going to do, and what I'm going to show you how to do this quite simply, we're going to use DynamoDB table here to do a replication of data between regions, and then everything is going to be independent. We're going to have an API gateway with Lambda Functions, and then what I'm going to do, I'm using Route 53 to do the routing between different regions, and I'll show you how the policies are working. So we started already with DynamoDB, blah, blah. Yeah, we saw this, yes sir, yes. I'll leave this in the slides so that you have access to it as well when you download the slides. And then I want to show you the Lambda functions. The Lambda functions are actually here. This is my, I have a bunch of Lambda functions. I have one called post, which is put data into DynamoDB. So as you see, you may have seen, I have a session ID, and then I have some comments. This is my Lambda function, create feedback. Basically, it takes an event and then put this to DynamoDB. And this is my event, all right? I put data into my table, into DynamoDB, and then I return a JSON object with that. So really straightforward way to build. And you can see my initialization of tables are done outside of the stuff. Here you can do this, but you don't have to do it exactly like this. You can directly access the region through the environmental variable here. This will tell you actually in which regions you are. It's the same way as how you would use a metadata API. So that is a good way to not hardcore, for example, your connections to DynamoDB. All right, so you see my DynamoDB actually connection will use the regions that is from the closest to the regions where I am. Okay, in that case. So if I'm in Virginia, it will configure directly to use the Virginia database and vice versa. So it's a good way to do that. Then I have another function called get, which I can retrieve this ID from DynamoDB. That's pretty straightforward as well. I get an item. This is my key feedback ID, and then I pass the ID. All right. And then I have a health check here. And this, I'll show you what I'm using it for. As you might see, it's very, very advanced health check systems. I strongly suggest you use similar very advanced systems in your environments. That was a joke, but it's for demo purposes. I always have to say it's a joke, otherwise I could be held responsible for massive failures that happen tomorrow in first database master crash, then health check crash. I've done my job. Great. And then, so you'll see here, I like the serverless framework, but I've deployed all those endpoints, all those functions using serverless framework. And here I have my DynamoDB tables as well. This is not the best way to do this, but I've done this for a test. I could explain later. And then I also created a template that you could use for for SAM, right? But let's do something interesting. Let's here return 404. So, and then let's do SLS deploy into the region east. this will deploy the function, the health function. And while it does this, I want to show you something. So where is my... So in Route 53, this is my dashboard. I'm using a traffic policy here for the domain that I'll show you. I have a traffic policy here, version 11. This traffic policy takes the CNAME and basically assign a 50-50 weight between the two different endpoints, right? So I don't do magic GeoDNS or anything like this. I just do a simple round robin. And what you can see here is actually evaluate target health, right? And I just deployed the Lambda function that is being evaluated. And you see before it was 200. And in Route 53, those health checks are checked regularly. So you'll see here my status. They were healthy until now because they were returning 200, right? But as soon as my function is going to be deployed, this is going to go into 400. This jitter because the policy requires that you have, for example, 4 errors in 3 minutes. So it's going to take time before that it starts to return errors. But you can see the health checker, the monitoring, and view last, fail check. That was some of those, right? But this was April 17, is today, and this was still, the last was still okay. So we'll try to refresh this as soon as, there you go. You see my health check already is returning 400. So now that's it. Now my policy is failing over to Europe. So all the data, all the traffic will go to Europe. All right? And we'll see the consequences after that. Cool. So now we are there. We've built the Lambda function. We've seen this. API gateway, I want to show you quickly how the API gateway is built. I've of course, through the serverless framework, when you deploy your Lambda functions, an API gateway with 3 endpoints was created, one with create, get, and health. And if you want to see, this is exactly what it is here into my serverless template. I have my get feedback, which is create feedback, get feedback, and then Lambda here. All right. And my path is health, create, and then get with the ID. So my API gateway has been created. Now what is interesting to see here, and you couldn't do that before, you need to create custom domain names. You can imagine by default API gateway comes with a CloudFront distribution which makes it global. And when you do routing, especially dynamic routing between regions, you don't want that, right? So you need to remove the API gateway, the default API gateway, and move into a custom domain name so that I can also have a domain name in Route 53 that is consistent with my API gateway. So what you can say, I brought my ACM certificate to API gateway and assign this to the API gateway here. And by doing this, it created what we call a target domain name. And this target domain name is actually created by the system so that you can do health checks on this. You see my health check is actually, I'll show you. My health check is using the target, the endpoint here. It's not my health check, it's my routing policy. Is using the target endpoints, okay? So you can do stuff like this. And this is very important because without custom domain name, you wouldn't have a consistent domain across your CNAME and then the all other API gateway endpoint that are being created. Okay, and this is now the endpoint. So I have this, and as I said, this is possible because of custom domain that you can do now in API gateway. And we already saw that policies, so now we have a system that looks like this. And we also know that my health check now is failing and pushing stuff only to you. And my API is quite simple. I'll create a new tab. And we'll do a post. My API is quite simple. You see back in the back, I had quite some information. I called the posts on the global DynamoDB or not me endpoint create, so it will call the create function. And then I pass some data into the body of the message, name, session, some score. Session score was 1, so not really good. It was a session on SageMaker by Julian, but I still think he's awesome. It was just a joke. And then you send that. That takes some time. There was none of the system was up, so it actually launched it was a cold start. And now the system should be replicated, so we can of course have a look at DynamoDB and see if my item has been there, and of course I have a demo effect. There is here my feedback ID here. There. Is it in the other region here? Of course not, because it's a good effect. Wonderful. Thank you very much for coming. So let's let the system to warm up a little bit. So we're gonna do a bunch of requests like this, so that we flood the system now. At least the Lambda function on the API gateway are warm and running. The Lambda functions for the DynamoDB stream should be starting to warm up as well. Right. This is just my request I hear at least. Yeah, they haven't updated this, so it means something funny is happening. Oh, of course. I so love these demos. Mom, I'm sorry. Oh, this is so funny. All right. What we can do is we can say actually we'll test the system. So now, of course, if I retrieve an ID that is not distributed, it should fail. But since my alarm, since my system is now only going to one region, I can retrieve the systems because it's one of the health check is now 4.4, so the system only send traffic to one region. And you can see actually, let's look at the Route 53 for a while before looking at what happened on the rest of the system. Tac, my health checks. And you can see now the US one is unhealthy, so that means no traffic will be directed there. So hopefully, if DynamoDB replication would start working, of course it doesn't work. So, well, wonderful. That's just weird. I've experienced issues with this table before. So let's delete all the items and see what I can do. Now you experience with the life of what it is to go on stage and do demos and fail them. That's cool. It's good stuff. I love this. All right, let's delete this one. All right, so now we are empty. Let's do another post. And let's hope this one will generate some traffic. Blah, 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 blah. I don't understand, because actually when I did the item myself, the system was working. All right, so obviously I have a problem with this database. So, but trust me, it works. Seriously, it does. Trust. All right. Anyway, I learned to live with failures. That's part of our role. So it's good stuff. Yeah. What's up? Unhealthy only affects Route 53 health checks. So it shouldn't affect at all DynamoDB global table replications. No. The table is empty. It's great you try to find an excuse for the systems. It just doesn't work today for some reason. So I mean, I really appreciate your help, guys. Please feed the. But that's just the way it is. Anyway, on conclusion, yeah, we learned about reliability and failures actually. So there's not much to say, right? So I'm happy to take questions. I just need to. I do a lot of demos with this table, so something might have happened. So and it just might be this. So I don't know what happened, to be honest. Yeah, I'll deploy the new health. So let's do like this. Let's put back to 200 and do SLS deploy US and see what happens. Maybe if I do from the US East, but it should replicate from everywhere. So, but absolutely. Oh, you're right. It's eventually consistent. Maybe tomorrow. What's up? No, I don't think so. I really appreciate you guys try to help, but actually you're right. What? Are you kidding me? Thank you. That's just weird. It works. Nice. So actually, for the sake of verifying, just because if it breaks, it's just fun to break until the end. Let's delete all the items so that we are there. Now all the items should be deleted here. Now they are. What's up? Yeah, no, now it's 200. Yeah, of course. Yeah, but I want to see if I do an HTTP post now here, just one. I'll have my ID here, and then is it now replicated to other regions? Yes. Party, beer, nice. I didn't say that. Sorry, Jeff. Just delete this, really. All right, I'm done. Thank you very much. Thanks for helping fix the demo as well. Any questions? I'm happy to take them. Like, I'm ready now. I'm super ready. Yeah, bring. Yeah, correct. No, so you bring just your Java code inside a package, right? And what we'll do when you deploy that, we'll start the JVM, deploy your code, deploy the dependencies, and then just run your code ourselves. You don't. Yeah, yeah, yeah. Right. So you're kind of touching the idea of hot start, cold start, and hot start. So when you don't use the system, there's no infrastructure created. So what we do is the first call that happens on your Lambda function, we give you a cluster of containers, Linux containers under the hood, with the right language that you want, so supporting JVM in that sense. So the containers in the infrastructure will have JVM. It will need to start, so it takes sometimes like 15 seconds sometimes, and then we'll have the code deploy and then call that function through the handler functions. And then if you don't use the system for 5 minutes, we'll shut it down. So if you reuse the system, it's hot and running. And you see the first request that I did on Lambda was quite slow, but then they are really fast, right? So you're talking on Route 53? TTL. Oh, no. Right, no, you don't pay. Lambda, you pay per execution, 100 milliseconds increments, right? If your Lambda functions to return takes 200 milliseconds, you'll be paid 200 milliseconds. We pay for the infrastructure for keeping it 5 minutes. But that's also why we need to shut it down eventually, because otherwise we would need to keep infrastructure up and running for everyone. No. You pay for Lambda. The pricing of Lambda is pay per 100 millisecond increment. And then the good thing is every account has 1 million invocation of Lambda for free per month forever. Right? So I've had customer coming on stage with me at the summit talking about how they do serverless in free tier. Because they have a million invocation, they use a lot of different accounts. Each of them have millions of invocations, and they just do like that. It's quite smart. Yep. What do you do? We need to do the math on what kind of EC2 instance and all that kind. Lambda functions are different than EC2 instance. Lambda functions are tuned by what we call memory, so 120 meg from up to 1.5, and then the memory was 3. Yeah, we just updated. Then the CPU is proportionally increasing with the memory as well. So it's like a power button, right? So you can't really compare to an EC2 instances. It's very different, right? But you know, customers that do, and that's what I said, Lambda functions is great. You need to have the right use case, right? If you want to do calculation that are longer than 5 minutes, very heavy, very, you know, do a calculation, right? That's the point. Most of the customers do save using serverless, but they add in sometimes complexity because there's new tools to understand, and we were discussing with the gentleman in front that, you know, those are new tools that you need to learn. If you have 100 Lambda functions, do the work. How are you going to manage this? Mono repos, no mono repos, all this kind of stuff. So it's adds, but it's for you to make the right call, I would say. Yeah, absolutely. It's an object implementation, right? Circuit breaker is just a way for you to implement or to encapsulate a request within an object. Is very doesn't have to. It can be per invocation, or you can use the cache. You can use memcache or Redis to keep the state of an object, of a circuit breaker object by ID inside Lambda functions. So you have a Lambda functions which as a circuit breaker that checks validity of a dependency and push that data into memcache so that other Lambda functions can use it as well. No problem. Never store the state of of any application inside Lambda or stuff like this. It's never the right thing to do because it might just disappear. So always use memcache, Redis, or systems to share states between instances through in-memory stuff. Yep. I'm sorry, I didn't hear the question. So the question is, what happened to the memory in the Lambda function of the Lambda function after it's executed? After 5 minutes, we wiped it up. Yeah. We do not guarantee that. So, and this is a good thing, is we do promote the reuse, for example, the initializations of databases and stuff outside of the scope of the function so that other functions can reuse it, because then it's initialized inside the memory. So for example, if you would have database pools and things like this, connection pools that you want to reuse, you can. And this is the right way to do it, right? Never initialize within the functions, because the function is rerun all the time, but not what is outside of the function. Right, so, but we do not guarantee. You always have to have a possibility to reinitialize things. Yeah. Yeah. So the question is, if you have an API gateway calling a Lambda functions, how do you authorize the call so that your Lambda function is not executed by someone that should not execute it, right? Well, you would want to do this on the API gateway, right? Make sure that your call is authorized through Cognito. Good way to do Cognito, AWS, Amazon Cognito, C-O-G-N-E-T-O is a service that allows you to authenticate your users using OpenIDs. It supports all the authentication things that you want, like through OpenID or SAMLs or things like this. And then you can run your own. You can actually write your own Lambda function that does custom authorizer if you have your own implementation of authorizations. Yeah, if it's a custom Lambda, then you have to pay if it's invoked all the time. Yeah, of course. So you would want to use WAF rules on your on your CDN, right, to expel the IPs that are doing doing DDoS on your IPs, right? I think there's the next session. Let's take it out. So thank you very much.